This is a video presentation of the notes for Chapter 7, Section 8 in the 8th grade textbook entitled Symmetry. So let's go ahead and talk about symmetry. Symmetry follows from our discussion of transformations last week. Remember, we talked about, at that point, we talked about the transformations known as translations and rotations and reflections. And this is really a play off of the concept of reflections, because a line of symmetry, when you take a figure and draw it, a mirror image over the line of symmetry, you're really creating a reflection. Alright, so what is line symmetry? A figure has line symmetry if you can draw a line through it so that the two sides are reflections of each other. Again, there's that keyword, reflections. That's why this follows our study of transformations. Line of symmetry is the imaginary mirror in line symmetry. And rotational symmetry, a figure has rotational symmetry if it can be rotated less than 360 degrees around a central point and coincide with the original figure. Again, line symmetry, a figure has line symmetry if you can draw a line through it so that the two sides are reflections of each other. Line of symmetry is the imaginary mirror in line symmetry. And rotational symmetry, a figure has rotational symmetry if it can be rotated less than 360 degrees around a central point and coincide with the original figure. Okay, so in number 1 here, they're asking us to complete the figure, and the dashed line is the line of symmetry. So where you see on my screen the two arrowheads, that is actually that line, right? And you are drawing the other half of the figure. So the lines go from arrowhead to arrowhead, arrowhead to arrowhead, and you only have, in your note-taking guide, half of the shape presented to you. So what you want to do is take and draw the other half of the shape that's not already been presented to you. Now, remember, if we had this on top of a coordinate grid, what would we have done? Well, let's say this is our x-axis here, and let's say that this point is 2 above the axis. Well, then its point that I reflected over has to be 2 the opposite direction, so 2 below the axis. Usually when we think of this from an elementary school approach, right, what we think of is we loaded a piece of paper up with paint, we were probably drawing a butterfly, and then we quickly folded them together, paper half and half, and then unfolded it, and what you had on the left and the right side of the paper, or the top and the bottom of the paper, depending on how you folded it, was a mirror image of each other, and that's how you first learned about reflections and lines of symmetry, or that line that you folded the paper down, the crease that you made the paper, would have been the line of symmetry. Notice here the two lines of symmetry to create in these here two perfect halves here, two halves that are identical. On the B side, this crown shape, again, same idea, even though it would be folded the other way here. For instance, this top of the crown, let's say it was 4 away from the y-axis, the other point would then be 4 away from the y-axis in the opposite direction. And that covers example 1. Let's continue on with example 2 here. We're supposed to complete the figure, and the point is the center of rotation. Now, what they say in the directions there is going to be something very similar to what you see, 2-fold, 3-fold, 4-fold, 5-fold, 6-fold in any given question. That's the number of times that that image is going to appear in a full revolution. So if I put my finger at any point on the grid and then do a full revolution, think of a clock going all the way around from noon to midnight or midnight to noon, however you want to go. In a full revolution, I'm going to see this L shape here 2 times because it says 2-fold. Right? If it said 3-fold, you would see it 3 times, 4-fold, you'd see it 4 times, and so on and so forth. Okay, so that said here, this one says 2-fold. So you're making this L show up over 360 degrees twice. Okay, well, we can do that. All right, that means I'm going to have it, since I divide 360 among 2, why 2? Because it says twofold. Every 180 degrees, I need to see this L happen. So that really means a 180 degree turn here for the next L. So if we say this L here points to the right, all right, 180 degree turn, doesn't matter which way I make it happen, all right, has to then appear going to the left, which would be this L shape here. Same L shape, turned around this point, because that's the fixed point. Remember, we kind of talked about the fixed point in a rotation last week. Well, that's pretty much what you're doing here. You're turning it around that point. Last week we would have turned it more around the origin, so it was a distance away. Now it's actually a point on the shape. So that one point, if we pretended those two were on top of each other, like we had cut them out and laid them on top of each other, and then turned it that 180 degrees, that one point is always going to be right there. Pretend like you're putting a thumbtack in there. Right? That thumbtack is going to hold that one spot always to that one location. And you can see they're saying the figure coincides with itself every 180 degrees here, because again, 360 turn divided among 2 L's would be 180. Last one here, they're asking us to complete the figure, and the dashed line is the line of symmetry. So the dashed line, as you can see from my arrowheads here, goes left to right, and they've given us this piece on top, so I want to reflect it going this way. Again, if you're having a hard time visualizing the reflection, pretend you had this on a piece of paper and then you took and folded it down and then quickly brought it back up. All right, well, that would be that shape that's created. That kind of a genie in a bottle type shape there that's created. All right, that is the completing the figure there. What you see above is exactly the same as what's below, because that's what a line of symmetry will always create.